This conference will now be recorded.
Very good evening, students. Today we are continuing discussions on the Neet UG paper 2023, which is just over. So we have already discussed many questions on this, many questions from this paper. We have few more to discuss. We'll try to cover as many as possible today. So this question says the radius of innermost orbit is 5.3 into 10 to the power minus 11 meter. Innermost orbit means we can say that is a Bohr orbit, A0. Bohr orbit is denoted by A0, sometime R0. That is given as 5.3 into 10 to the power minus 11 meter. Okay. What is the radius of the third allowed Bohr orbit? What is the radius of the third allowed orbit of hydrogen atom? Okay. So third orbit of the hydrogen atom we have to find out. So there is a direct formula to find out the radius of any orbit. Rn is equal to n square into a0. What is this n? N is the number of orbit. If this is 1, then anyway you will get Bohr orbit. If it is n is equal to 2, that is the second orbit, and n is equal to 3, that is third orbit. So here you have been asked to find out the radius of the third orbit. So we'll take n is equal to 3. So we'll write here the radius of the third allowed orbit of hydrogen atom. Hydrogen atom is sometimes written H atom. H atom means hydrogen atom. That can be obtained as R3 is equal to 3 square into A0. That means 9 into A0. A0, the value is this 5.3 into 10 to the power minus 11 meter. Okay, now if you multiply this, 9 is 27, 2, so 9, 5, so this is 47, and this is 10 to the power minus 11 meter. But here these are given in terms of angstrom. Angstrom is 10 to the power minus 10 meter. So let us do this by 10 into 10 to the power minus 10 meter. This is nothing but 4.77 angstrom. So this was also very simple question. Good. So the option C will be correct here. Now this question, so the net impedance of the circuit shown in the figure. See, impedance, this is very easy question, and what you require to do is just remember the formula of impedance. Impedance is given by Z is equal to R square plus capacitive reactance minus inductive reactance whole square. Now we have to see R is given 10 ohm, that is fine. We have to find out this factor. Let us first find out what is Xc. This is called capacitive reactance. Capacitive reactance is written as 1 by omega into C, and here frequencies are given, I think. Yes, omega C is given. So here frequency is given 50 hertz. So frequency means not omega. 2 pi, the frequency is omega. So That means we have to write here 1 over 2 pi into the given value 50, and c is given as 1000 by pi, 1000 by pi, or 10 to the power 3 by pi. So this pi goes off, and you know what you get? You get, see, ultimately here you will see 2, see this will be 100 again, so 10 to the power minus 5. Okay, 10 to the power minus 5, and at the same time this was 10 to the power minus 6 microfarad. So if you want to make it farad, this, actually there was another factor, I'll just rewrite this part. C is microfarad. Okay, I need a larger space. See, this is 1 by 2 pi, f is 50 hertz, c is 1000 by pi into 10 to the power minus 6, which I can write here as 10 to the power 6. Okay, so microfarad means 10 to the power minus 6 farad. So as I was doing, I can do it 10 to the power 6 by 10 to the power 5. Okay, 10 to the power 5 was come. It will be 10 to the power 5 because here 2 zeros will come. So you are getting how much? This will be in terms of ohm actually. This will have unit of ohm. So you will get 10 ohm here. Similarly, XL, if you want to find out, so that is just omega into L. What is omega? As you know, 2 pi, F is 50 given here, 50 hertz, and this is millihenry. You can see that 50 by, again 50 by pi millihenry. That means 10 to the power minus 3. So this pi goes off. See, here it will be 5. See, 5 to the 10, so this is 100, and this is another, so you will get actually 10 to the power 3 here, 5 into 10 to the power 3, and 10 to the power minus 3 is there, so you'll get this as ohm, so you'll get 5 ohm. Okay, you get 5 ohm from here. So then XC minus XL will be 10 minus 5, which is again 5 ohm. Okay, so now if we just put it here, this factor we have already obtained. See, this is 10 square, and this is 5 square. Okay, that means square root of 125, so which will give you 5 root 5, because I can make this 125 as 25 into 5. 25 can come out as 5, and root 5 will be there. That is, this is in ohm again. So see, we have got 5 root 5, and oh my god, this is not the desired one. This is 5 root 5 ohm. So this is the option. Okay, so let us go to the next problem. This is also a very interesting problem from kinematics. Okay, so what is here? A bullet from a gun is fired. So a bullet from a gun is fired on a rectangular wooden block. Let us say this is rectangular wooden block. We don't know what is the total thickness. We don't know that. Let us say that is some T, or let us say thickness is D. Thickness is D. So a bullet from a gun is fired on a rectangular wooden block with speed u. So a bullet is fired, and which actually come and hit this bullet, come and hit this with a speed, initial speed. What is that speed? That is u. Speed was u while hitting here. All right. The bullet, when the bullet travels 24 centimeter through it, suppose it comes like this. So 24 centimeter it travels already, and this part is actually d minus 24. Yes, this is d minus 24 centimeter remaining. So the okay, so when bullet travels 24 centimeters through the block along its length horizontally, velocity of the bullet becomes u by 3. When this bullet, after traveling 24 centimeter, it comes here at this particular position. Here, the velocity of the bullet becomes this. That means it is getting decelerated. Okay, decelerated. So the bullet is getting decelerated. But what is the deceleration? We don't know that. Okay. Now let us read. Then it further penetrates after reaching 24 centimeter. Its velocity becomes 2 by 3. But anyway, it is not stopping here. It is further penetrating the block in the same direction before coming to rest exactly at the end. So at the end, it just comes to rest. Okay, at the end, other end of the block, it exactly reach here and stops here. Okay. All right. So now the total length of the block you have to find out. Okay. See, there are two parts of this question to answer. First of all, we need to find out the question is to find out the thickness or the length of the uh, rectangular block. And the clue is here is that, see what happens generally when the bullet starts penetrating that particular point onwards, it will give some resistance. Okay, the block will give some resistance to penetrate it, isn't it? So that resistance will actually gradually reduce the speed of the bullet. So when the velocity is reducing, that means there will be a particular rate of reduction of the speed, and that is called deceleration. So we have to find out what is the deceleration. We know initial velocity, we know the distance where this final velocity is obtained. So we can use the simple equation of this kinematics third equation, I say. So v square, this is the final velocity, and u square, that's the initial velocity, minus 2a is here. Acceleration is, this is not acceleration, this is deceleration. That's why I'm writing minus a, and this comes here. See, v, the final velocity is how much here? Is u by 3. So u by 3 whole square minus u square, and that is 2 into a which we have to find out, and s is 24 centimeter over here. So now look, this side is actually, this is minus 8 by 8 u square by 9, and this is minus 48 a. So what is deceleration? The magnitude of the deceleration will be 48. So this will be 6. So u square by 54 meter per second or centimeter per second, whatever it is. We are not going into that unit part. Anyway, it will be taken care. Since I have used 24 centimeters, so it will be centimeter per second square. Say. Now, what we have to find out, we have to now find out what is the thickness here. So same formula we'll be using here. We have obtained this thing. Then I have to find out what is S. Same formula we'll be using. Let us say this is here S1, and now it will be S2. So S1 is this much, S2 is this much, so this much. So here initial velocity, see, we have to find out S2. So here we have to use the same formula, b square is equal to u square, b square is equal to u square minus 2as. So b square, anyway it will be 0, u square is u by 3, and then it is minus 2 A, we know we have got A as U square by 54 into S1, sorry, S2. So what is then S2? S2 will be is equal to, see, U square by 9 with a minus sign, and there here will be minus. Okay, this S2 is here multiplied. So 54 will go this, and this will come here, and U square also will be here. So this will be plus. Now look, this goes off, and this will be 6, and this will make it 3. So S2 is found to be 3 centimeter. Okay, so S2 is 3 centimeter. This distance is 3 centimeter. Okay, so what is the total distance? So that is D is equal to S1 plus S2. S1 was 24 centimeter, and S2 we found 3 centimeter. So which is nothing but 27 centimeter. So what is the length of the rectangular block? That is 27 centimeter. Okay, all right, we'll go to the, okay, here you look, this D, option D is the correct answer in this case. We'll move on to the next problem. Okay, so calculate the maximum acceleration of a moving car so that the body lying on the floor of the car remains stationary. Calculate the maximum acceleration of a moving car so that the body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is this. See, that means, you know, there is a so there is a car, okay, and on the floor there is some object, say, let us say there is a block. So this car is actually moving forward with certain speed. Question is that the car is accelerating, but what will be the maximum acceleration such that the block doesn't slide over the floor, it remains stationary. So how it happens? When generally any object is moving or just on the floor of a moving car or moving train or any vehicle, so that, see, if this has acceleration A, this object also will have acceleration A. Okay, but then if the mass of this block is small m, the force on it in the forward direction will be acting as m into A. And see, since there is a friction between the floor of the car and this object, the object will be stationary till then, or until then, when the frictional force in the opposite direction will be exactly equal to the force over here. Okay, so what is the frictional force? F, and that F is equal to mu m and g. This is the maximum static friction. So mu mg. So therefore A max will be here. Maximum acceleration will be mu g by, sorry, mu g, just that, mu into g. What is this mu? Mu is given coefficient of friction, static friction, that is 0.15, and g is given as 10 meter per second square. So how much you get finally 1.5 meter per second square. So this is the acceleration with which the car has to move. This is called maximum acceleration of the car, such that the body on the floor will not move at all. It will actually be in static situation. Okay, so the option B will be the correct answer in this case. We'll go to the next problem. So this is also very easy problem. This is from electricity. So this is related to the combination of resistances. Combination of resistances. Okay. Just I'm sorry, there was some internet fluctuation, so I need to stop it in between. All right, so we'll move on to the question itself. So in this question, it says there are there are 10 resistors. 10 resistors, each of resistance are connected in series. So how many resistors are there? There are 10 resistors, each of resistance R are connected in series to a battery E and to a battery of EMF E and negligible internal resistance. That means if you if you consider this is the battery, okay, and with that there are 10 identical, okay, 10 identical resistors are connected in series. All right, fine. Then those are connected in parallel to the same battery. The current is increased in n time. That means the resistors are first connected in series with this battery. Then when the resistors are connected in parallel to this battery, current is changed and that increased n times than the previous value. So let us first find out when 10 resistors are in series. So when they are in series, then the total resistance, okay, total resistance of the circuit will be 10 into R, isn't it? R plus R plus R, so 10 into R. So what is the current in the circuit? EMF is E and total resistance RT, that is E by 10 R. Okay, E by 10 R. All right. Now, when the 10 resistors are connected in combination, parallel combination, then equivalent resistance will be, see, 1 by R total, I'll write here, or R prime total is equal to 1 by R plus 1 by R, like that it goes up to 10, right? 10 resistors, such 10 resistors, so it will be actually 10 by R, isn't it? Identical, so 10 by R. So what is R prime total? R prime total is actually, or R total prime is R by 10. Okay, R by 10. Now what is the new current? This is the resistance. Then new current I prime will be E by R prime total resistance. And what is that? This is R by 10. So 10 will be going here in the numerator, and this will be R by 10, right? So look here, this E by R, this value, if we can make use of. So E by R is actually E by R, this is equal to 10 into I. So there will be a relation between new current and old current. So E by R is becoming 10I. Okay, 10I. That means it is becoming 100 into